Hi, my name is Maria Perez.
I'm Austin Pearson.
And I'm Nicholas Hammond. And we were group 15, and we were tasked with coming up with an object-oriented software design, and we decided to design a restaurant. Overall, we wanted to do a lot of things, and we wanted our restaurant to be able to manage all of its employees, their schedules, and the costs with paying your employees, ordering foods, ordering ingredients for the restaurant, possibly even paying rent for the building, all of the things associated with that. And we decided to follow the design process that we were taught in class. So we started with coming up with some actors, some use cases that the restaurant needed to have. And we started whittling it down after seeing how big it was, narrowing the scope, and we limited the design that way.
Okay, so this is our original use case diagram. We originally have the manager have 5 different use cases, which include order supplies, update budget, change schedules, hire employee, and fire employee. We ended up, because we wanted the program, we felt that it really didn't, like financial operations did not fit the scope of the program. So we ended up removing the order supplies, update budget, and change schedules use cases. Also, schedules were also, it's not financial, but we felt that it was beyond the scope of the program to really have the employees and other such actors have schedules. So at the end of the day, manager really just only has 2 use cases of hire employee and fire employee in the final project. Additionally, the store, which is really just the restaurant itself, we also did not have like any shipments or any calculation of gains or losses through restaurant orders, because again, that really deals with financial problems that the restaurant might face.
So this is our interface that we started with. This is the employee interface, and we also created a restaurant customer interface. For the employee interface, we had the employee name, the checkout time, check-in time, clear for next employee, and then some sorts of keyboard to input the names and numbers, and a screen to display the information. For the restaurant to customer, we had the food item names, add items, remove items, some sorts of keypad to input what they were going to order, and a screen to display the order list, and also slots to pay with a card, cash, change return, and to print out the receipt. And for the final interface, we came up with these 3. We added a chef interface, which will display the orders from each of the tables, and also a menu item to display what is available. And the middle interface is to place in the orders, to hire in the employees. For example, manager has hire employee, fire employee, print employee list. For host to see the customers. For waiter to check out the customer after they're done eating. And for tables to select the current table, add tables, and to see the available tables. And for file to save or load the information for each table.
So this is our class domain model. When we first started off, we had some of the previous functionality mentioned still in here, such as the bill and things like that. Some of the interactions have changed, such as the menu, not having like the bill as a separate thing, but rather than just having the total in it. And that total doesn't have any financial functionality, it's just for display, for the customer to know what their cost is. The other big change is that the table class is now included in the restaurant, as we've added the functionality for the restaurant to add tables.
going into detail, we have the different packages that incorporate these classes. And this is pretty much, beside the changes I mentioned, our final domain class model.
Right. So now I'm going to demonstrate the functionality of the system. So we can see that we have a menu, the menu interface, which we can't edit, and we have the middle interface. The middle interface does most of the operations of this code. So the first thing we're going to do is test serialization by going to File and Save. So now nothing is currently in the restaurant. There's no tables, there's no employees. So whenever we hit load, we should basically empty out most of the interfaces back to how you see them right now. So let's begin by adding a chef. Let's just say Chef Carol. We can add her. And you can see that she gets added to the employee list. So let's hire a waiter. Just Will, and Will gets added to the list, and you can add a host. Also, I should mention that in this restaurant there can be several waiters, but there can only be one host and one chef. So when you try to update host or chef, I'll demonstrate this really quickly. Their name will basically be replaced. So if we want the employee name for chef, let's say Courtney instead of Carol, we can see that when we open the employee list, that Courtney is up there. And to demonstrate fire employee, let's just say we're going to fire the employee Bob. Now Bob isn't in the employee list, so when we try to fire him, it'll say he doesn't exist. But when we try to fire an employee that is there, let's say Will, the waiter, he gets fired. So let's add him back, just because it's fun to do that. Fun to mess with him. So add Will the waiter back, and we now have Will the waiter, and Courtney is of course the chef that we changed. We changed her name. So now to add tables, no tables. We can hit this add tables under the table menu, and we can just type in a number of tables to add. So I'm going to add 2, and we can see that now there are 2 tables that don't have any customers because they were just added. So now that we have employees and tables, we can now add customers. So customers, when they come in, they get seated by the host, and let's say that James comes in with a party of 4. So James gets seated at the first available table, which we can see now. It's been removed from this list. And also, if we go to tables and select table 1 is now available for choosing an order. So let's make an order for table 1 by doing add item. So I added fried chicken. Now we currently have it set so that there's only one order of fried chicken available. So if we try to add it again, you cannot add fried chicken because there's not enough chicken. Additionally, you notice that this little button popped up when I added the end of the order. And basically this button, when you click it, it will remove another couple things of the order to demonstrate. When you click this button, it removes the last thing that was added to the order. So it basically treats this order is basically implemented as a stack, and this button just pops an item off the stack. So fried chicken, and let's have this order, and let's have them place the order. So now this is the order that has been placed for table 1 to the chef, and when the chef finishes the order, they basically will hit this finish order button and go back, and this will get removed. Before that, let's say table 1 tries to add another item. They can't do that because the order is already in place. And you'll even notice that the button has been removed to basically remove items from the list. So their order cannot be changed. Once you place the order, you cannot place another, and you cannot add or remove any items.
So you get what you get. Now I'll add another table. I'll see another customer really quick just to demonstrate what happens when we finish orders. So really quick, I'll make another order for customer. Let's just say we want a cheeseburger, Caesar salad, and we don't want chicken, that's out. 2 cheeseburgers. Okay, there we go. So this is the order for table 2. Place the order, gets added to the chef interface. And now when the chef hits finish order, you can see we get a notification saying that table 1 has been completed, and table 2 is now the topmost order, and table 1 has basically been completed. We can do it again, complete table 2, it gets removed from the queue. So now the chef is basically done with work. So now what happens, when the customers are done eating, they get checked out by the waiter when they're ready to leave the restaurant. So the waiter enters the table number after the customers have left, and they hit OK, and they clear table 2. So as you notice, table 2 was right here, and now table 2 no longer has any information. Like that information was basically removed, and that is the case here as well. So and even in the available tables, table 2 is not here because there are no longer any customers there. So now we can demonstrate the serialization, the load function, by going to table 1. You can see that there are not any tables here, or that there's currently an order at this table. The customers have yet to leave, but instead of checking them out how we just did, I'm going to just load in the data that we had originally, and you can see that table 1 gets removed, and there are no longer any available tables, and that there are no longer any employees. Okay, so off screen, I have basically reinitialized certain employees. So you can see that there are 2 tables, and there are and that there are 3 employees: a chef, a host, and a waiter. And now I'm going to seat customers. What I'm going to demonstrate is the functionality of the program's waitlist, which basically, when you add customers and all the tables that build up, so let's say, we just add James, let's say Kelly with 4. So so now in the available tables, there are no tables available. The customers have been seated at them. So when you try to seat a customer after this, let's just say Howard comes in, and he has a party size of, let's say 9. What happens when we do a party size of 9? Oh, we get an error saying that the size needs to be between 1 and 8. So let's say Howard comes back, and he puts party size of 7. So now he gets added. But wait, there are no tables available, so instead he gets added to the wait list. So what happens with the wait list is when the waiter checks a customer out, let's just say so at table 1 there's a customer. When this happens, table 1 will get cleared, and the first person in the wait list, which is treated, and the wait list is basically a queue, is implemented as a queue, and the first customer in the wait list, or whatever gets popped from the wait list, will be added to the table that has been cleared. So Howard was the first one in the wait list, so he gets added to table 1.